Okay, well, we're here to report our findings. And here's the thing, we're just trying to find the length of the cardioid. Here's the R equals 9, 1 minus sine theta. It's not that this problem is necessarily, this question is hard. It's not complicated. Let's start by graphing this. So we'll start by taking a look at our graph. It's gonna look something like this. And it's kind of silly little drawing, but yeah. So we're gonna want to be integrating this from 0 to 2 pi. I mean, at first you'd be thinking you might want to be trying to find the limits of graphing. Should we go from pi over 4 to pi? Where should we do it? Honestly, because it's polar, I don't think that matters too much. I think we're just able to go from 0 to 2 pi with no question. Even though it seems like, hey, it's symmetric right here, right? Should we be adding this half and then multiplying by 2? Should we be starting here and then focusing on that? Trying to calculate us? Nah, I don't think that. I think that's mainly for parametric equations. If you're polar, polar equations are chill, man. You can just start at 0 and go straight to 2 pi. Just add it all up, and Shazam, you're gonna get the answer. That's pretty cool. Polar coordinates are awesome. Now, that's only for using R's, okay? So we just have to remember what's the equation for the length. Let me just look over here. It was this, that's right, 0 to 2 pi, and then we're taking the square root. We're taking dr over d theta squared plus r squared, and then that's over, d theta. All right, dr over d theta is not too bad. Let's just try to rewrite this as 9 minus 9 sine theta first, and then what we can do is just kind of, the derivative of that is really just negative 9 cosine theta. All right, and then you're just going to square that. Plus r squared, that would be 9 minus 9 sine theta squared. And what are you going to do? You can go ahead and put this stuff back in there if you want. Let's go ahead and try to simplify this a little bit. So 81 cosine squared theta plus 81 minus, there's going to be a 81 minus 81, so this is minus 162 plus 81 sine squared. And then, let's do this again. At this point, we're going to try to pull out an 81 from this. So 81, and here's a cosine squared plus 1 minus 2. I forgot to write sine. Plus sine squared. And then this is all going to be like square rooted over here, So after this, this is square rooted as well, actually. Shazam. We can pull out that 81 and it becomes a 9. And you get the square root. Cosine squared plus sine squared is at 1. Plus 1 is 2. Minus 2 sine theta. Awesome. That's really easy now. Yeah, okay, well, we're gonna go ahead and pull out 9 square root of 2, and then we have the square root of 1 minus sine theta. And at this point, well, it'd be hard to do this. Sine 1 minus sine theta. So we want to get this to be sine squared theta. If we could do that, then it'd be really easy, because then it'd just be sine theta. So how do we get that to happen? Well, let's remember that if we have sine squared theta, isn't that just equal to 1/2 times 1 minus cosine 2 theta? And so let's make this sine squared of theta over 2 equals 1/2 of 1 minus cosine theta. Alright, now don't we know that cosine theta, or actually really sine theta, is equal to pi over 2 minus theta over 2. Actually, I prefer to do this with theta first here. Just go ahead and do that. It's actually theta over 2 minus, no, not theta over 2, put that on my thing. It's, theta minus 90 degrees, pi over 2. Alright. Sine theta equals theta minus. Gosh damn. Sine theta equals cosine theta minus pi over 2. Alright. So the point is that we have this down. And now we can start going on. This is kind of difficult. Sine squared, and then we have 1 minus cosine theta. So that means that cosine theta, that'll be this. Let's go ahead and put that in there. 1.5, and then we got 1 minus cosine of theta minus pi over 2. And that's equal to sine squared of, will it be theta minus pi over 2 divided by 2? So that would actually be theta over 2 minus pi over 4. Alright. Okay. Well, if that's the case, let's go ahead and multiply 2 on that side. 2 sine squared theta over 2 minus pi over 4. And then we have that equal to 1 minus cosine theta minus pi over 2. Alright. And it's getting kind of small over here, which is kind of crazy. But I think we're getting somewhere because it says that, remember that cosine of theta minus pi over 2 is equal to sine 1 minus sine theta is equal to 2 sine squared theta over 2 minus pi over 4. And isn't that what this is? Nice, so that means I can put this in for that. And so over here I'd have 0 to 2 pi, 9 square root of 2, and then this is a square root of 2 sine squared theta over 2 minus pi over 4. Alright. And there we go. So now what we can do is we have this this new thing here. 0, 2 pi, 9 square root of 2, and then there's the big square root of 2 sine squared theta over 2 minus pi over 4. Well, it turns out that, you got square root of 2 times square root of 2, so it's really just 9 times 2, and then that's just sine of theta over 2 minus pi over 4. This is still going from 0 to pi over 2 to 2 pi. Well, here's an 18. And then we're going to do a u sub. U equals pi over 2 minus, or sorry, square root of 2 minus, we're going to do this little du equals a half d theta. So 2 du equals d theta. And that means that if we try to plug in for our limits here, let's see. So the first one is theta equals 0, and then the second one is theta equals 2 pi. And if we do that, and when we put in 0, 0, it's negative pi over 4. And then over here, it's going to be 2 pi minus pi minus that is 3 pi over 4. And then, this is where we just kind of, there's this whole thing about absolute values here. And I really don't know how to how to deal with all that. It's kind of too complicated. So we're just going to assume that it's positive here, you know, because this is square root. If we were to graph this, hold on a second, because we're looking at, we're going to look at a graph later. We're looking at 18, and then we're doing a u sub. So really it's sine of u, and then there was a d theta over here that we're going to replace for 2 du, and then that's going to be 36 sine u du, and this is supposed to be integrated from negative pi over 4 to 3 pi over that. But if we were to look at a graph of this, it turns out to apparently be a circle or something. And so because it's a circle, we're allowed to basically just integrate wherever we want. You know, you look at the graph and it's just a circle. I'm pretty sure even if you're supposed to integrate from here to there, just to set it proper, for some reason it only works properly if it's on the proper region. I'm not too sure what's going on here, but we have to set this equal to, we gotta add a pi over 4 here and a pi over 4 here. I think that's because probably because of this, you know, I don't know, we move this over pi over 4. Honestly, I have no idea, I'm just reporting my findings. But apparently after we do something like this, we're supposed to set this equal to 0, the pi, adding that pi over 4 over there. And take us to 36 sine u, and then now we're supposed to integrate, you know? I mean, I don't really see why or how, but it kind of makes sense, I guess. It's if it's a circle, I suppose you can do something like that, you know, kind of makes a little bit of sense. This apparently gets you the correct answer, so now you'd have negative 36, I don't know why it's negative actually, but negative 36, well, yeah, I don't know why it's negative. What's going on? Okay, yeah, you know why it's negative. I'm just a little tired, because when you plug in cosine of pi is negative 1, so you get 36, and you're supposed to subtract 0, which is negative 36, that's plus 36, so you get 72, which is the answer. Yeah, so, I mean, if you didn't do this, pushing this thing over pi over 4, you wouldn't get the right answer. And that's kind of weird, you know. So it's possible that, you know, when I was integrating this, I was looking at it a little bit like this. I was kind of just looking at this section over here, the original section, sine, 18 sine of pi over 2 minus pi over 4, and I was thinking to myself, okay, I mean, do I really have to like do an use up here? Probably not. I can just go negative cosine, and then the derivative of the inside of this is just a half. So you divide all this by a half, and then here's your 18 over here from the beginning, and then you just put your pi over 2 minus pi over 4. So this will work, because then you multiply this by 2, you get negative 36 cosine of pi over 2 minus pi over 4, and this is supposed to be going from 0 to 2 pi, but I think maybe we might want to add pi over 4 or something to this. Let's see if we did that. If we get the right answer, pi over 4, and then what's 2 pi? Pi over 4. That's gonna be 2 pi. pi over 4. Let's see if this works. So 9 pi over 4, because, like, look, it's like kind of offset by this negative. Let's add that there to our thing. And you know how we have to subtract that from here. I think this is correct. I'm not too sure. I don't think this is how you're supposed to do this, though. Maybe, who knows? I'm just trying this stuff out. Let's see what happens. 9 pi over 4, and then we've got a negative 36 cosine of our pi over 2. Let's go like that. And then, well, now I did our integration already. So 0, or pi over 4. And this is 9 pi over 4. So let's see if that works. Negative 36 cosine of 9 pi over 8. I don't think that's gonna work. Anyway, this one was really hard. I don't know what to say.